Okay, welcome to the next lecture, and we will continue chapter 6. And in this chapter, we will study the frequent pattern analysis. Frequent pattern analysis is, in fact, a pattern having a set of items, subsequence, substructures, etc. that occurs frequently in a data set. So, for example, if you find a database of a store and you will find the purchase of some items are frequent than the others, so it is in fact is a frequent item set. And there would be some sequences. For example, if you buy a product, so what is the possibility that you will buy the next product with some support and confidence? And there is some substructures and you will have some other substructures of the pattern as well. So actually, this in fact is frequent item sets have some association rules. And if you just review the assignment 1, which I have given you, so you have performed this association rule mining over the affinity data set. So there are certain motivation behind this. One motivation is you want to find out that which products are frequently purchased together. For example, you have seen that beer and diapers are usually purchased together. So that is a frequent pattern. So what are the subsequent purchases after buying a PC? So in a subsequence, a frequent subsequence is that which product you will buy after the purchase of the PC. Either it will be a software, it will be a printer, or the antivirus software. So there are different possibility that if you buy a PC, you will buy the software for it, or you will buy the antivirus for it. So, or you will buy the printer after buying a PC. So there are some subsequences which are followed for the purchase of the products. So what kind of DNA are sensitive to the drug? So this is also used for biomedical application. And next is, can we automatically classify web documents? So this is also in fact used to classify the web documents, and we have discussed this before. So there are several applications. It is used for market analysis. It is used for cross marketing, catalog design, sales campaign analysis, and weblog analysis, and DNS sequence analysis. So there are a lot of applications for this frequent pattern analysis. So this in fact is frequent pattern mining is in fact is the essential task of data mining, which is in fact is They are performed with association, correlation, and causality analysis, sequential structure and subgraph patterns, and spatio-temporal, multimedia, time series, and string data, and for classification, discriminative frequent pattern analysis, frequent pattern-based clustering and data warehousing, semantic data compression, and other broad range of applications. So first, we review the concept of frequent pattern. That what is frequent pattern? For example, we have a record of 5 transactions, and in these transactions, there are several products purchased in each transaction, and we have different item sets in each transaction. So it might be 1, it might be 2, it might be 3, and it might be 4, and up to the possible number of products available at the store. So we have to find the frequent patterns. For this, we need to calculate the absolute support and the relative support. Support is, in fact, is the number of count or the frequency of occurrence of an item in an item set. For example, say if we want to see the frequency of the beer purchased from the store among these transactions is 3. So this is, in fact, is the support count or the minimum support, the absolute support or the occurrence of an item in an item set, right? Similarly, we calculate the relative support. Relative support is, in fact, is that how many times the beer is purchased among the total transactions, and we will find its probability. So that is, in fact, is the relative support, that how many fractions of transaction we have purchased this item beer. So the item set X is frequent if its support is not less than the minimum support threshold. So we have to set the minimum support threshold to find a pattern frequent. For example, if we didn't set the criteria for minimum support, so we cannot extract which product is frequent. Because in the item set we have many possibilities, but if we don't have the minimum support threshold criteria, so we will not able to find which product is more frequently purchased, right? So the minimum support criteria is used to find the frequent pattern. So association rules, in association rules, we will see that the X product implies Y product with minimum support and confidence. For example, we have the two products, beer and diaper, and we will want to find the association rule that beer uh, and diaper are purchased together, and diaper and beer are purchased together, and we will set some we will find the association rules with some level of minimum support and minimum confidence criteria. So for example, the minimum support criteria we set is 50%, and minimum confidence criteria is 50%. So what we will have to find the frequent pattern is, in fact, is we see that beer is purchased 3 times, and nuts are purchased 3 times, diaper are purchased 4 times, and eggs are purchased 3 times. So we will have this from these 5 transactions, right? So this in fact is the uh, frequent pattern, and we will find the association rule between beer and diaper. So for this beer and diaper, so what will be the sport criteria? So what is the sport criteria? That we will find the probability of X union Y, that the both products X union Y here is they are purchased 3 times together. So the sport will be 3 out of 5 into 100 is 60%. And similarly, we will find the confidence probability that a transaction having X also contains Y. So in 3 transactions, we have purchased beer, and for all these transactions, we have the diapers. So we are 100% confident that a person purchased beer will also purchase diapers. So the confidence is 100%. But if the association rule is followed, that a person buy a diaper will buy a beer or not. So for this, we have to check it again. Uh, for beer and diaper, or diaper and beer, whatever the combination it is, so it is purchased 3 times together. So the sport is still 60%. But the confidence, how we calculate the confidence, that how many transactions we have the diapers. We have 1, 2, 3, and 4. 4 transactions we have the diapers, and among this, only 3 times the person purchased the beer. So the customer purchased the beer 3 times. So it will be the probability that 3 out of 4 into 100, which is 75%. Now we actually uh, have seen a very little item set in which we have a few products. But if we have consider an item set with 100 products, or we are interested to find the patterns. So there are how many possible patterns for it? For example, if we are trying to find just one product, so how many combinations? So it is a combination of 100 out of one product. So if we want to find two products, so there are 100 out of two combinations. And similarly, if we want to find the 100 out of 100 products, so it will be 100 by 100 combination. So how many possibilities or how many possible patterns? So there is a large number of patterns which are extracted from the purchases. So it may be 2 raised to power 100 minus 1, or it would be a very large number. So we cannot mine the frequent pattern. So how can we mine the frequent pattern? So we have a solution that we will find the closed patterns and max patterns instead. Instead of mining the frequent pattern, first we find the closed patterns and the max patterns. So we will go into the definition of the closed pattern. First, we see the example of the closed pattern. So we have see the two transactions in the database in which first transaction has A1 to A100 item sets, and the second transaction has A1 to A50 item set. So we have the minimum support criteria for this is 1. So how we could find the value of the closed item set? So closed item set is in fact is how many times the customer purchased A1 to A100 products. So he purchased 100 products just one time. So there is only one transaction in which we have the 100 products purchased. So we will have this sport 1, and A1 to A50 is in fact is also the subset of this first transaction. So A1 to A50 is in transaction 1 and in transaction 2. So A1 to A50 has two counts. So its count is 2, or its support is 2, right? So both of this is in fact is have the satisfy the minimum support criteria. Now look into the definition. So if X, an item set X is closed, if X is frequent and there exists no super pattern with the same support as X. So there is no super pattern with the same support as X. So we will see here that this A1, A50 is in fact has a superset A1 to A100, but it doesn't satisfy the support criteria of A1 to A50 because 2 is greater than 1. So it means that it is the closed item set. Also, A1 to A100 is the closed item set because it don't have any superset. So if it don't have any superset, so it satisfies the minimum support criteria, so it is the closed item set. So we in the closed item set we have these two values, and among these two, which is the maximum pattern? So the maximum pattern is in fact the maximum item set will satisfy the minimum support criteria, that is 1. So we will go back and look into the definition. An item set X is a maximum pattern if X is frequent, because X A1 to A100 is frequent because it supports uh, 1, and there exists no frequent super pattern, and there is no frequent super pattern of A1 to A100. So in this way, we will find the maximum pattern. Now, actually, how this closed item set and the maximum pattern help us to find the value of the uh, frequent patterns. So we can find the value of the frequent patterns with the help of this closed item set. But maximum pattern will not help us to find the value of all frequent patterns. So the only closed item set helps us. How it helps? For example, we will see a product A1. So A1 also supports the minimum sport criteria because its sport is 2, and that is above the minimum sport criteria, so that pattern is frequent. So in this way, with the closed item set, we will find all the value of frequent patterns in the item set. So A1 to A50, all the item sets have the uh, minimum sport, have the sport of 2, and from A1 to A51 to A1 to 100, we have the sport of 1. So all these item sets will satisfy the criteria of minimum support, and they are frequent. So despite of having a huge combination, we are able to find the frequent patterns with the help of these closed item sets. But we are not able to find all the frequent patterns with the maximum pattern. So, so there is the computational complexity of frequent atom sets mining. So, in order to resolve this complexity, we will in fact study the frequent item set mining methods. So to resolve the complexity, we will look into the methods, and among these methods, there are several methods among which in this lecture we will study a priori, a candidate generation and test approach method. So in fact, a priori method is in fact will be discussed in today's lecture, and the next we will cover in the next lectures, and we will also see that how can we improve the efficiency of the a priori algorithm. So first we study the downward closure property and scalable mining methods. What is a downward closure property? Downward closure property is in fact any subset of a frequent item set must be frequent. For example, if an item set beard, diaper, and nuts is frequent, so its subset, which is beard and diaper, is also frequent. Or in other words, we can say that every transaction having beard, diaper, and nuts also contains beard and diaper. So, in fact, we will use this closure property in a priori algorithm. So, a priori candidate generation and test approach. For this, we will study the a priori pruning principle. If there is an item set which is infrequent, so its superset should not be generated and tested. For example, if for example, if I say here back here, for example, if reversibly, if I say that beer and diaper is infrequent, so beer, diaper, and nerds will be infrequent, and we will not find the sport of beer, diaper, and nuts. So because beer and diaper is infrequent. So this is in fact we apply the closure property here for a priori pruning. So so any item set which is infrequent, its superset should not be generated and tested. So we will look into this method. First, we take an example. So how this a priori algorithm works. For example, we have 4 transactions in which we have the different item sets, and the total products are 5: A, B, C, D, and E, right? So we will scan for each individual item set. So for each individual item set, we will have the candidate list for one item. So we represent it by C1. So this candidate list is in fact is A, B, C, D, and E. So what is the sport of this? Sport of this is 2. Because we count here A occurs 2 times. So the frequency or the count of A is 2. So its sport is 2. Similarly, we will find the count of all the items, right? And in this, in fact, is we have the corresponding sport of each item. So we will have the frequent list. Frequent list 1 is in fact is generate only those items which satisfy the minimum sport criteria. So here the minimum sport criteria is 2. So we have the candidates A with sport 2 and 3 and 3 and 3, and D with sport 1 is in fact is not in the frequent list because it didn't satisfy the minimum sport criteria. From this, because these candidates, these frequent list have this frequent list have the uh, frequent pattern satisfy the minimum sport. From this, we generate the candidate to list or the list of 2 candidates. So in fact, we have AB. So we have AC and we have AE. So we have AB, AC, and AE. And then we have BA, but order is not important because AB is already available. So we have AB and BA is same. So we will just have BC and BE. So we have BC and BE. Similarly, for C, we will not have CB and CA because AC and BC are already in the set. So we have only CE. So we have only CE in the list. So how you can do it? For A, you will have the combination with all. For B, you downward all the combination, and C, you downward all the combination. So you have AB, AC, A, B, C, B, and C. Now you have the second scan for AB and AC and AE, BC, BE, and CE in the table. So what is the minimum sport for this? You will scan it from the table that AB is only occurs 1 time and its sport is 1. And similarly, we count the sport for all the candidates for 2 item set. So we will see that AB and AE will not satisfy the minimum sport criteria, and we will choose rest of the items from the candidates list to the frequent list, and we will have the corresponding sport of these items. Now we will use pruning method here because you see here in the pruning method, if beer and diaper doesn't have the doesn't satisfy the minimum sport criteria, or they are infrequent, so it means that beer, diaper, and nuts are also infrequent. So we use this rule to prune this result, and we have also see that if there is an item set which is infrequent, its superset not be generated and tested. So here we list, we have A, B, C, ABC. In ABC, we have the AB which is not in the list. So it means that ABC is also eliminated. Also, we have the BCE, BCE. So we have BC, BE, and CE. All the combinations satisfy the minimum support. So we will only accept B, C, and E. Also, we have BCD. BCD is in fact is also not in the list, so it's already pruned. So we have also, because D is here pruned, so it means that we will not take it as a candidate. So we will have from this frequent list, the only pattern we have is BCE in the candidate list, and we have this minimum support is 2. So the next we cannot proceed because we have only one combination left, and this is the frequent pattern in this list, and you can verify it from the database that BCE in transaction 20 and 30. So it occurs 2 times. So this way you can apply the a priori pruning algorithm to find the frequent patterns. But in fact, we have to see the problem with the a priori algorithm. For example, if we have the transactions of 1 lakh or 100,000 transactions, so it means we cannot scan all the database, so it creates problem. So we look into this problem later on. First, we will see that the pseudocode for this a priori algorithm. So this method scan database once to get frequent one item set. So so you will find the scan the database for frequent one data set. Then you generate length k plus 1 for the candidate item sets from length k frequent item sets. So L1 frequent item sets, this L1 frequent item sets, you will generate C2. So here you have seen that from L1, you have generate C2. You will generate C2 with the frequent list items. You generate the candidate list too. So we have the candidate list k plus 1 from the k frequent items. Test the candidates against the database, and we test the selected candidates from the database, either they are frequent or not. So if they are not, so we terminate the candidates which are not frequent and generate the next candidate set. So for example, we have the CK is the candidate item set of size K, and LK is the frequent item set of size K. Then L1 is the frequent items from which we begin. For K is equal to 1 and LK not equal to 5, so we increment the loop, and we will have the CK plus 1 candidate list from LK. For each transaction T in database, do increment the count of all candidates in CK plus 1 that are contained in T, and then we have LK plus 1 list candidates from CK plus 1 with minimum score, and then we terminate the loop and return the value to LK. So this is in fact is the pseudocode of this a priori algorithm. Now we look into the problem which we have in this algorithm. So the main problem is that if we have the transactions of 1 lakh or 100,000 transactions, so it's very difficult to apply this a priori algorithm because the difficulty of scanning a large database is problematic. So because we have to scan the database several times, so how can we improve the efficiency of this a priori algorithm? So yes, we can improve the efficiency of this a priori algorithm. So for this, we have some solutions. So one solution is here we look at reduce passes of transaction database scans. So we reduce the number of database scans. How can we reduce the number of scans? We can just reduce it to 2 times scan. So how can we reduce it into 2 times scan? For example, we have the 100,000 databases. So we partition it into 100 partitions, and each partition has 1,000 transactions. So we will have say 100 databases, and in each database we have 1,000 transactions, and we will have find the frequent pattern in each database, right? So this frequent pattern is calculated from each database, and this is called the local frequent pattern. So we have the local frequent pattern of 100 databases, and then from these local frequent patterns, we consolidate the global frequent pattern. So in this way, we have to scan the database for 2 times only. So first is for the local frequent pattern, and second time for the global frequent pattern. And the other is the basically is in fact is the DHP, reduce the number of candidates. And actually we will first discuss the scanning problem, and then we discuss how to reduce the number of candidates. So again, we have the sampling of frequent patterns. So, for example, we take 10 samples from the 1 lakh transactions and mine the frequent pattern within a sample using a priori. And we apply the a priori approach to find the frequent pattern. Then we scan the database only once to verify that this frequent item sets from the sample is frequent in the database or not. So how can we do this? That we have the frequent, we have the borders, or we scan only borders of closure of frequent patterns. And how this, we see this, that we check ABCD instead of checking AB, AC, etc. Instead of scanning the instead of checking the 2 item sets, we will check the borders of the closer frequent pattern. For example, if ABCD is frequent in 100,000 database, so we only scan the database once, and we will find that ABCD is frequent. If it is frequent, then it's all combinations AB, AC, and AD are frequent. So we only check the border. And also, if it is infrequent, so all its sub-patterns are infrequent. So sometimes a sample frequent pattern is not frequent in the database, and we find the missed frequent patterns and scan the database again. In this way, we avoid the multiple times we are scanning the large database. So now is the direct hash partitioning. You reduce the number of candidates in the candidate set. So direct hash partitioning is, in fact, we have the hash basket, and we have the count of this. For example, we have the hash basket for 2 item sets, and it has AB, AD, and AE, 3 candidates, and we check the count for this. This is 35. And if this count is below the minimum support, so we will say that this pattern is not frequent. So all the candidates of the 2 item sets, for example, AB is not a candidate of 2 item set if sum of count of this AB, AD, and A is below sub threshold. So we will choose only those 2 item sets which supports the minimum support criteria in this hash basket count table. So this is in fact is a one hash basket second, and this is another hash basket, and each hash basket has the count given in this table. So now we have the direct item count method. Direct item count method is in fact is I give you two examples of this method. For example, this is in fact is item set lattice, and we have all the possible item combinations here. And for example, we find A and D are frequent, so we count AD as well, right? And if, for example, we have the two subsets of B, C, D are determined frequent, the counting of B, C, D begins. For example, if we count that BC and BD and CD are frequent, so we will start counting BCD. So it means that if we are counting the items in one item set and found it frequent, so we will start it counting in a two item count. And similarly, if all the patterns of BCD, sub patterns of BCD are frequent, like BC, BD, and CD, so we'll start counting of BCD here. So this is, in fact, we have studied uh, a priori pruning algorithm used for data mining, and we also discussed the way we improve the efficiency of a priori algorithm. And in the next lecture, we will focus on other methods. So this is frequent pattern growth, and the other methods, frequent pattern mining with vertical data format. So thank you very much for joining the class, and inshallah see you in the next week with other methods. Allah Hafiz.